which was not designed for this type of debris, right? So people who are responsible for maintaining the pumps and the sewer systems, so in some cases get called 2 or 3 times a week to clean these pumps out in a confined space, and they never fail. Once those fiberized solids make their way through the treatment system to whatever sensitive downstream process there is, but they're going to cause problems. Either they're going to cause shadowing in the UV system, or they're going to cause problems with the life of the membranes. Chute, and this chute can be 30 to 40 feet vertical to the surface, driven by the ride-on belts, but most of them are trending wheels. And the issue that operators have with trending wheels are that the bearings in those trending wheels fail fairly regularly, and they can start to close up over time, which requires them to be cleaned. And so people talk about the fact that 100-year storms are coming every 2 years or every 5 years, and that creates something really challenging at the headworks section. 2 models of it, the IQ, which is everything other than the open and close, and the IQ squared, which includes everything that I told you earlier, plus the open close feature of the system. So
I'm here with Mark Turpin with Duperon. Thanks for meeting with me today.
well, thank you.
Can you give me just a high-level overview of what you guys do?
Sure. Duperon Corporation, we do primary treatment, so primarily screening, and what we've been known for is screening in municipal wastewater. We do stormwater, open channel type work, a lot of pump protection and downstream process equipment protection. That's our claim to fame.
So you guys are on a mission to really help screen out sewage.
Yeah, we're on a mission to provide simple, resilient equipment that transforms the way operators interact with the equipment. So really what we're trying to do is to produce equipment that's very highly effective in screening, but that requires very little maintenance or maintenance costs throughout the life cycle of the equipment.
All right, so speaking about equipment, we've got a piece here. Kind of, what are we looking at?
Yeah, so this is a machine, a little screen that's designed to fit way out in the collection system. So you imagine this screen deals with the issue of flushable wipes. And the idea here is it sits way out in the collection system, say in an 18-inch manhole at or near a hospital or a daycare facility or some community that's generating a lot of flushable wipes. And the strategy is to remove the wipes there before they wreak havoc all the way through the collection system in the wastewater treatment plant, which they are today.
So what about the rags, the wipes that create such a problem downstream?
I think the biggest issue is that people believe that they're branded as being flushable. So people believe that because they put them in the toilet and they pull the lever and they go away from their home, that they actually are flushable.
Yeah.
When in reality, they're anything but flushable from the standpoint of the municipal sewer, which was not designed for this type of debris, right? So that creates problems throughout the system with pumps, a lot of pump fouling. People who are responsible for maintaining the pumps and the sewer systems, so in some cases get called 2 or 3 times a week to clean these pumps out in a confined space, and they never fail when it's work hours. It's always when the daughter's soccer game is and the guy's got to come out, get down to the confined space and get this pump back in operation. So what the industry's been doing to solve the problem is they've been chopping or grinding these rags so that they will pass through the pump that's right there, which sometimes works, but often those solids recollect with fats, oils, and greases, and they create what's called fatbergs. You may have heard about fatbergs in sewers downstream, or they go all the way through the system, make it through the screens at the sewer plant, end up in sludge pumps and recirculating pumps and clarifiers, or in the contact tanks, or ultimately out into the receiving body that's taking the discharge from the wastewater treatment plant. So all we're trying to do is simply get out ahead of the problem at or near the point these wipes enter the collection system and remove them before they wreak all that havoc on the system.
Okay, so what the current solution a lot of times is they'll grind it up, shoot it downstream, and that has like tons of unintended impacts at the wastewater plant. I think MBRs don't like having those kind of pumps in their system, and it clogs those up.
Yeah, I mean, if you think about as the debris gets fiberized, right, The typical headworks screening equipment isn't designed to take out that type of fiber. So whether you have a membrane downstream or you're using a UV disinfection system, once those fiberized solids make their way through the treatment system to whatever sensitive downstream process there is, they're going to cause problems. Either they're going to cause shadowing in the UV system, or they're going to cause problems with the life of the membranes. So anyway, from our perspective, the way we think about it, a simple small screen but up in the beginning of the process where those rags enter the collection system is the best way to return that system to its designed performance. It is very capable of handling the normal flows that it was designed to handle. It just wasn't designed to manage this huge amount of flushable wipes that seem to be entering our system today.
All right, so when you're designing one of these flushable wipe removal systems, what are some key components here the operator needs to consider, and how do you guys kind of meet those?
Yeah, the core unit itself is based on a technology that we use in our washer and compactor, and we've been using it for decades. So very similar to the way that we do that, just in a different orientation. This is a vertical orientation versus a horizontal orientation. It's made up of a screening unit here. The screen has two augers inside, so that as flushable wipes are entering the screen in this direction, they get caught in the augers and against this bar screen. They're pulled up, the augers end about right here, and then they're pushed in a chute. And this chute can be 30 to 40 feet vertical to the surface, but there's no auger in this chute. So the debris itself is just packing in the chute, being pushed to the surface. Once it gets to the surface, it can either come above the surface and discharge into a bagger unit that's in a dumpster, or you can terminate the chute here below the manhole cover and schedule a vac truck to come in, on a 2 or 3 week cycle and pull the solids out of the chute. So it's essentially you're removing the unplanned maintenance associated with flushable wipes in the way we treat them today, and you're replacing it with garbage pickup schedule.
Gotcha. Which is, I'm assuming, a lot cheaper than replacing parts at your wastewater plant.
Anything you can plan for is cheaper than the things that are emergencies. Right?
Than what were you saying? The guy leaving his daughter's softball game to come deal with the lift station.
Yeah, emergencies never occur when it's convenient. It's always Super Bowl Sunday, or an important event for your kid, and you're responsible for protecting the community's welfare and equipment, and you're the person who has to show up out there to do it. So we're trying to eliminate those types of headaches with this piece of equipment.
All right, cool. So what are we looking at here?
This is an internally fed drum screen. So it's a screen that sits outside of the channel, and flow is pumped to it. And it's designed to handle very fine debris, and it's protecting sensitive downstream processes. So in a municipal plant, it would be protecting downstream membranes or some other type of sensitive system downstream. And it's internally fed, and it's a rotating drum screen.
Okay. So when someone's speccing it out, looking at picking a new one, what are some key highlights they should be considering?
Well, for this particular machine, I can tell you what we designed it around and maybe why it's a little different than another drum screen. So we did voice of the customer on drum screens, talking to operators and what their experience and pain points are with drum screens. Really, three things continue to emerge. The first thing was the chains and sprockets that are used to drive these machines tend to be a maintenance issue, and throughout the life are something that they spend money and time on trying to maintain. The second, and the I think most important thing, is that drum screens, almost all the drum screens ride on something called trunnion wheels, or they're ride on belts, but most of them are trunnion wheels. And the issue that operators have with trunnion wheels are that the bearings in those trunnion wheels fail fairly regularly. And that failure mode requires an operator to get inside the unit, jack up the drum, unbolt the trunnion wheels, and there are sets of trunnion wheels, replace them with hundreds of dollars of repair parts, and then lower the machine back down and put it into service. Now, it's a lot of work, but it's also a lot of work in a place you really don't want to be working, which is underneath the machine. So Trunnion wheels were a big issue. And then the third issue that we heard a lot about was if you have an upset condition like a lot of grease that comes in, or you've lost power in the plant and the screen has blinded, it's very difficult and unpleasant to get up inside the screen and spray the machine to clean it. Or if you have to do any kind of maintenance inside the drum, it's really difficult to access it.
So you're kind of saying this gets clogged up with those greases and stuff, and it's not actually functioning.
Yeah, it can also get clogged up with like calcifying, mineralizing things like struvite or other types of mineralizing, and they can start to close up over time, which requires them to be cleaned. And so that was something else we looked at, is how do you access the drum and how do you change the game on how you're maintaining this type of equipment. If you're an operator, this is your responsibility. So, yeah.
Can you show me kind of how you guys clean it, or?
Well, yeah, I can. You want me to talk you through each of the three things?
Yeah.
Yeah. So first of all, when we thought about chains and sprockets, Terry Duperon, the founder of the company, one of the things that he had as a design criteria when he first started inventing things was a little saying where he says 2 parts are 1 part too many. So every time we think about a problem, the first thing we think about is, why does this part even need to be here? Like, why do we do it this way to start with? And so when it comes to chains and sprockets, what we decided was that you really don't need them at all, because you can direct drive the drum. And so what we're doing is driving the drum directly from the drive system without a chain or a sprocket. So the way we solved the chain and sprocket issue was we eliminated it. Now, trunnion wheels are an important part of these screens because they give it a support system, something to ride on. But what we did in this case was we put a water lubricated bearing on the opposite end from the drive. This water lubricated bearing gets constantly washed, and it also gets lubricated with water. So essentially the bearing itself rides on a shoe. The shoe is lubricated with water as the bearing surface is entering the shoe. And so essentially there's no need for a trunnion wheel because this bearing surface is replacing that trunnion wheel in the design. So again, the way we solve for trunnion wheels is we just eliminate it.
Just eliminate them completely. Yeah, less is more.
Now you have this one bearing system as opposed to the sets of trunnion wheels that you would typically use. And then the third thing that we did was, this drum is actually constructed of panels. So if you do need to access the drum, you simply take a panel off. You can move the panel out away from the drum and spray it off, inside and outside. You can jog the machine to the next panel and do the same thing. So you never have to get up inside of the drum to clean it. And all of that maintenance is done at chest level. So you're not having to get under the machine or inside the machine. You can do it all at chest level. The same thing with the bearing. If you have to replace the bearing gets replaced right here with 2 bolts. Take out 2 bolts, take out the bearing, replace it with a new one, jog it to the next one, you do the same thing. So the idea with this machine really is to change the experience that the operator has with a piece of equipment, such that they have time to do the other important things in the plant, and they're not focused on constantly trying to keep this machine running so the downstream equipment isn't being contaminated. So
you're not trying to create more work for them.
That's right. We're just trying to really reduce work.
And
by eliminating parts. Yeah, that's right here. General classification, this is a multi-rake bar screen. It's a front clean, front return, multi-rake bar screen. And they are fairly common headworks equipment for screening out debris ahead of downstream equipment.
Okay. And I see it's moving right now. So how does it kind of operate?
So the screen's driven from above. And the unique thing about this screen is that there's not a sprocket or a shaft at the bottom of the screen. And the reason that's important, and this is the original design that Terry came up with for the FlexRake, Terry Duperon, for the FlexRake. He removed those parts at the bottom because what he was trying to do is eliminate binding at the bottom of the machine. So what will happen is a 2x4 will come in here or a 4x4 will come in. And when the scraper, if there's a sprocket and a shaft below, when the scraper interacts with that, it tends to want to jam. And then if it jams, it trips the machine out. And if it trips the machine out, an operator has to get down in the channel and clear the jam. So Terry's original thought was, why do we do it that way? And so if you eliminate that apparatus below and you change the design of the link system such that it works like your knuckle or your elbow, the chain itself or the link system itself will be the turnaround at the bottom. And so that was the original design. Now, we've been doing that for 30 years. And as you might imagine, doing something for 30 years, you learn a few things about the environment that it's in. So we've changed a few things on this model.
Wow, fast. So once again, kind of going back, that vision of just like that less is more, or two is one too many.
Yeah,
that's
the first. 2 parts are 1 part too many.
2 parts are 1 part too many. I think a lot of people can relate. Just simpler is usually the better solution. I think a lot of people try to overcomplicate some of these processes. Is that kind of the philosophy?
Well, where our customers work, the simpler, the lower maintenance that you can design into your equipment, the better it's going to be for the people who have to live with it for the 20 or 30 years that it's installed in. So that's really front of our mind when we design anything. It's really easy to make something complicated and do a job. It's really hard. I mean, really, really hard to take a problem and design the simplest solution that you can to that problem. But what that does is it transforms the owner's interaction with that machine throughout its life. So that's what we're trying to accomplish. So now, with that in mind, one thing that we learned about bar screens in general is that bar screens can be susceptible to what we call a perfect size stone. And this creates a maintenance issue because if the perfect size stone gets between the bars on this screen, the teeth on these scrapers tend to interact with that stone in a way that it bends the tooth. And if it bends the tooth,
then it's not pulling at the bottom. It's missing.
Right. So then the alignment is off and it can cause damage to the bars and other components in the screen. So this was an issue that we saw with all bar screens, all rake style bar screens that occurred with enough frequency that we needed to solve it. So we did that on this new design. This is a FlexRake IQ. It's our newest design. We did it by changing the material construction of the scraper, but also by changing the profile of the teeth on the scraper, such that when the teeth interact with the stone in the bar, you're jammed in a bar, they will strike and then nudge the stone. And by that 2-step process over and over again, we found that you can work the stone out as opposed to driving it up to a cross member where you will bend a tooth or cause damage to the screen in another way. And the material of construction that we changed to is more resilient under those forces, such that in all the places we've installed the IQ screen, to my knowledge, we've never had a bent tooth. And so just a different way of eliminating a problem. So we saw for that issue. Another thing, the original machine we operate at this slow speed, 24 hours a day, 7 days a week. And the idea about operating at a slow speed is that it creates the least amount of wear throughout the life of the machine.
Because there's less friction or less heat being generated from that speed?
Yeah, less work being applied to the components, right? So we run slow and steady the whole time, which works really well. There are some cases where you would want to be able to clean the machine more aggressively. And we're finding that's happening more and more with our customers. So you've heard people talk about the fact that 100-year storms are coming every 2 years or every 5 years. And that creates something really challenging at the headwork section. So if you think about, you're running a plant that would normally see 5 million gallons of flow a day. But during these 100-year storm events or these unusual hydraulic events, you're seeing 25 or 30 million gallons a day. Now you have a plant that you either have to design for 25 or 30 million gallons a day, or you have to figure out how you're going to clean very aggressive. How are you going to manage that max peak condition that occurs? And so as we were thinking about that problem, what we did was we built some intelligence into the machine so that the machine itself, when you're in a condition like that, I guess what I should say is when we're in a condition like that at the headworks, it's not so much about the hydraulic event. It's more about the solids event, because with the screen, you need to keep the solids off of the screen, cleaned out, and the hydraulics will pass through the machine. That's the goal of screening. So what we're thinking about is, how do we handle first flush events where you have a lot of water flowing through the pipes that scours grit and tricycles and anything that found its way into the collection system, a lot of grease, and all of that shows up almost instantaneously at the headworks. So what we've done is we've designed the machine to sense when a head differential is building ahead of it, and it speeds up to 4 times the normal operating speed. So the first thing this screen will do is speed up to 4 times the normal operating speed, so it's cleaning the entire bar field every 7 seconds, and it's removing up to 4 times more debris than it would in this slow operating speed.
This normal one.
Right. And then after that, as the head differential begins to go down, the machine will slow down to this operating speed, and it will operate under this condition for 95% of the time when you're in average flows. And that's really the FlexRake IQ in a nutshell. There are some other features that we've done around the link that have changed the link design, but that's it in a nutshell. Now, we also have a feature on this we call the FlexRake IQ squared. Now, the FlexRake IQ squared goes one step further. So let's say that I'm dealing with a 100-year storm event, but I want to be able to screen at the finest possible opening for that 95% of the time when I'm running at average flows. But I know I'm going to have a 100-year event. So how do I get the best of both of those worlds? How do I get the finest screening possible during normal flows, and still the peace of mind of knowing that I have enough capacity that when I get that 100-year event, I'm going to be able to manage it? So what we've done with the FlexRake IQ squared is that we have a machine that, let's say that you design it in quarter inch opening for average flows. If you get that event, that big 100-year event, the screen will first speed up, like I told you on the IQ. If you continue to build a head differential ahead of the screen, even at high speed, this machine will automatically open to the next bar opening size. So it's designed at quarter inch, but when you get that event, the screen senses a head differential and it speeds up, right? And then if the head differential continues to build, it knows it's at high speed and there's still a head differential, the bar field will open to a 3/4 inch opening. Then it will operate at high speed with the 3/4 inch opening until the head differential begins to lower. As it lowers, the screen will close while the raking mechanism is still operating in high speed, cleaning the returning screen multiple times. Then when the returning screen comes home, the screen will slow down to its normal operating speed. So 95% of the time you're operating slow and steady at the finest possible screening, but you have the peace of mind of knowing that the screen itself will respond to the storm. You don't have to change the design. So that's this screen. We have 2 models of it, the IQ, which is everything other than the open and close, and the IQ squared, which includes everything that I told you earlier, plus the open close feature of the screen. So really interesting solution to a number of problems that occur in the wastewater treatment plant. We feel really good about the design. Yeah, and so far our customer's been very happy with this unit. So
that's awesome. Mark, thank you so much for doing this with us.
Thank you, we appreciate it.